describing ever more complex motion. Last time we were talking about Galileo's inclined plane experiments. 400 years ago, it was beautiful, simple, elegant little experiment of marbles running down a lamp. They are deceptively simple. They are deceptively simple. They are some of very big ideas of science that are developing as Galileo is thinking about and articulating what is needed to do such experiments. He's looking not just at the science, but at the meta-science issue. So you have to make a decision. You have to reduce friction. You have to reduce gravity. You have to think about what measurement tools you are using. You have to come up with some clever timing tools. You are deciding to manipulate nature purposefully in order to learn something about nature rather than just straight observation of the world around you. You are quantifying the data, trying to have numbers that are rigorous. You are being very careful about your definition of the words and the terminology. You are deciding about units and measures. All of these things are part of the practice of the scientific method, which the future scientists appreciated and have used to greater power over the years. The result of this experiment was a direct contradiction to Aristotle's writing. Aristotle said very clearly that a heavy object and light object, when released and subject to the force of the gravity, should strike the ground at the very different times. It's not his language, but rephrased in the contemporary language. Yeah. The heavy things should reach the ground first, and so you have to appreciate the huge social implication of demonstrating very clearly, in a way that was easily reproduced. That is not correct. So you're questioning where I am, where I was. You are questioning the wisdom of the ancients, and in fact demonstrating that is incorrect. So think about all of the ramifications. Think about how uncomfortable this might make a church that in that era, which has made a certain public statement about how the world works, and in particular about astronomy, which we will be coming back to. So Galileo is certainly on the verge of something very big, and we really haven't talked enough about the result of his measurements. That's what I want to focus on today, and we are going to start for about the first half of today's lecture with the kinematics alone. Kinematics is a description of the motion. So I'd like to think about some of the other words, some of the words that I've been using casually, speed, velocity, and accelerations. And we are trying to define these, and we are trying to understand exactly what we mean by them. We will find that the acceleration is the most subtle at all, and it's also most the fundamental in the physics. When you are talking about the rate of the change of something, that's very, very important idea, and we'll see it over and over again in our course. This is the first important example that is it's not only it is not only the thing, but also the rate at which the thing is changing. That is each separately very importantly. Once we have described the kinematics, once we have been able to define these words, we will discover it's more than just description. You can predict the future if you know kinematics. If you know the kinematics, kinematics is a velocity, for instance. And if you know the velocity, and then you should be able to predict where it was before and where it's gonna be in the future. So kinematics is already a part of the physics which can be very useful, and it's going to guide us to ideas that are yet more fundamental. We are going to start asking, but why? Why is it velocity what it is, and why is it changing the way it is? And that's where we are headed. Let's start with speed. We defined the speed last time as the distance you travel divided by the time you took. Okay, so again, we defined the speed last time as the distance you've traveled divided by the time you took, and if you wanna be really careful, let me call the if you're really careful, let me call this is average speed. It is average because I'm measuring this speed. It is average because I'm measuring your speed over some finite chunk of time. If you are driving to a destination, such as driving to the grandma's house, what you want to know most likely is your average speed for the trip. You want the total distance and the total amount of time, and it really doesn't really matter so much, and you're sort of assuming that you have some less stops along the way. You'll speed up and you'll slow down. What you care about is the average. Now, if your average is 60 miles an hour, then that carries a lot of information. If you say it's a steady 60 miles per hour, there is extra information there. So let's think about 60 miles an hour. It's already fruitful to analyze such a little simple term. 60 miles in 60 minutes. That's 1 mile in 1 minute. I've just changed the unit from hour to minutes. So you can do that anytime you are talking about physical quantity. I can measure the time in hours, in minutes, in seconds, or years. You choose. I can measure the distance in miles or feet. So it's just a calculation. If you know how many feet there are in the mile, you can pull out your calculator, and I argue you to try this out and check for yourself if 60 miles an hour is 88 feet per second. Oh yeah. So 88 feet per second means every second as the clock ticks, you travel another 88 feet or 27 meters. These numbers, of course, you can't compute in your head. You have to have done them on a calculator and remember them. 60 miles an hour is such a common speed that I happen to know those unit conversions. But otherwise, you simply need to know how many meters there are in the mile, or how many meters there are in the foot. You look it up, and it is a human convention. the word steady, it carries some information. So if it is a steady 60 miles per hour, so it means your cruise control is probably on, and it's 88 feet every second after second. And so here is when I'm arguing, knowing kinematics predict future. If you're going to steady, if you are going to a steady 6 miles per hour on the highway with a cruise control on, then you know exactly where we're going to be in the 2 hours. Barring some unforeseen change in 2 hours, you are going to be 121 miles further down on the road. You also know how far you are going to be in the 10 minutes. 10 minutes is 10 miles if you are going 60 miles per hour. If that went by too fast, think about it. Convince yourself. Really, what I'm doing is little algebra problem in my head, and we are pretty used to that on the highway. When you look at the science, it's especially easy at 60 miles per hour because it's exactly 1 mile per minute. You can do this in your head, but what you're doing in your head is the algebra problems. Speed equals distance divided by time. 60 miles divided by 1 hour. That's what you mean by your speed. And Galileo is thinking about speed without using this kind of algebraic relationship, and I'm not quite sure how to think about it in his way. It's also more awkward, so there is probably no need to go back to that old mathematics. Yes. Distance divided by time is a ratio. I don't think of it as a template to plug numbers into my calculator. It's telling me something. It's what speed is and how far you go every second. And the fact that the steady 60 miles per hour tells me that ratio is a steady. So if I go for twice as long, I'm going to go twice as far. And that's more of the Galilean way of thinking about it. The ratio stays constant. Yeah, it's a function. That's what we mean by speed or average speed. But in physics, we are often interested in what's going on now and what's the instantaneous speed. So what do I mean by that? Well, that's exactly what you are looking at when you are looking at the speed meter. Yeah, speedometer. Oh, yes. Oh, you say, oh no, now I'm going 60. Oh now, I'm hitting the brakes. Huh. Now I'm going to 50. Now I'm going to 40. When you say now I'm going, you're thinking about instantaneous speed. And when the police officer pulls you over, it's not going to do you any good to say, but officer, my average speed for this trip was below the speed limit. The officer will say, yes, but your instantaneous speed was above the speed limit, and they know the difference between the instantaneous and average. You can be going 60 miles an hour, and you don't have to go for an hour. So 60 miles per hour right now just means that so 60 miles per hour right now just means that if I were to go for an hour, then I would go then I would go 60 miles. So it makes total sense to talk about your instantaneous speed, but you have to think carefully about how you measure that, because it's very easy to measure the speed. It's very easy to measure the average speed. You just lay out of the ruler, and it makes total sense to talk about your instantaneous speed, but you have to think carefully about how you would measure that. it's very easy to measure average speed. You just lay out with a ruler. You see how far you went. You start the stopwatch and you end the stopwatch. Yeah. Average speed is easy to define operationally, but instantaneous speed is a tricky business. So what could I mean by that? Well, let's see. If I'm going to 60 miles per hour, what I really mean is let's figure out how far I went in a pretty short amount of time, like 1 second. And if I went 88 feet in 1 second, that's an average speed of 88 per second, average over the 1 second, and that's short enough time that I might say comfortably, okay, I'm going to 60 miles an hour. But technically speaking, what you really mean is 60 miles an hour I'm going 60 miles an hour. Technically speaking, what you really mean is 60 miles an hour over an arbitrarily short amount of the time. You have to think about taking the limit as you measure it over shorter and shorter imaginable times until you are down to some infinitesimal little time. And the way your automobile really does this in the practice is by measuring the amount of the time it takes your wheel to go around one revolution, which is a very short amount of time. Time, yes, of course, your automobile knows how big your tire is, and also it knows how far your automobile has traveled. Yeah. So if you measure the time for the wheel to rotate once, then you can figure out your average speed over that incredibly short amount of time, and that's what the speedometer is reading. Now we talk about instantaneous speed. We can talk about the change in that speed. So I can be going 60 and then I can go slower, then I can go faster, and those words mean something that faster means faster means a higher instantaneous speed. Slower means a smaller instantaneous speed, but oftentimes, but what you care about in real life is how rapidly you are going from fast to slow, or from slow to fast. Think about the difference between the fancy little sports car sitting at the edge of the road on ramp, trying to move onto the highway, and an old Volkswagen microbus. Okay, each one of them is at rest. Each one of them wants to be going 60 miles per hour, which is the flow of the traffic on the highway, and they're going to do in a different way. Let's think about the sports car. You jump on the gas, and in these seconds you're up on the highway at 60 miles per hour. That's a spectacular change in your speed in a very short amount of time. This distinction between how fast you are going and how rapidly your speed is changing may seem obvious, and then it's one of those ideas that are going to slip away. We are going to keep talking about the rate of change of something, because it's absolutely critical that we distinguish between how fast you are going and how rapidly you are changing your speed. If you stop, then the difference between the rapid acceleration and slow acceleration, a large or small acceleration, is going to be enormous. Wow. Acceleration is going to be defined as the rate of change of speed. That is to say, how much faster I went divided by how much time it took me. The rate at which the speed is changing is the acceleration. How are we going to measure that? What unit would we use? It's not a mile per hour, that's a speed, and I'm talking about how rapidly you changed. For instance, for that sports car, it might be mile per hour per second. Let's think about it. We went from 0 to 6, so that was a change in the speed of 60 miles per hour, and it took us 3 seconds. It took us 3 seconds to change by 60. That means 60 divided by 3, that we were changing by 20 miles per hour every second. That is the acceleration. So then 20 miles per hour second would be the acceleration of a very, very good sports car. 20 miles per hour per second. What does that mean? Well, after 1 second, how fast is that the sports car going? It started at 0, now it's going 20. 1 second later, it's now going 40. 1 second later, and now it's going 60. It will be 0, 20, 40, 60 miles per hour. Every second, it's increasing by another 20. What about Volkswagen microbus? Let's suppose it takes a minute to come up to the highway speeds. You are charging away, and there is a little bit of headwind, and maybe you are going up the hill. Your acceleration will be 60 miles per hour divided by 60 seconds, not 20 like the sports car, but in this case, 1 mile per hour per second. For each second, the Volkswagen microbus is going 1 mile per hour faster. Now, both started at the rest, and they both ended up going 60 miles per hour on the highway. The fact that they have very different accelerations, one of the 20 in these units and one of one in these same units, doesn't tell me about where they started or what they ended up at. It just tells me about the rate. This distinction between the speed and rate of change of speed in the tricky business. If I tell you I have a motorcycle and I'm on it, and I'm speaking on my cell phone, which would be readily dangerous on a motorcycle, and I say my motorcycle has a huge rate of acceleration right now, am I going fast? You have no way of knowing. I'm telling you that I'm accelerating rapidly, but I might be telling you that just the moment that I started, I might be accelerating at 20 miles an hour per second, but I've only been accelerating for half a second, so I'm not really going fast yet. Or I might be telling you after 3 or 4 seconds, and then I really am going too fast, knowing my acceleration all by myself, by itself, knowing my acceleration now does not tell you my speed now. The two things are connected. Once you know one, it helps you figure out how the other one is changing over time.